All right, how's it going today? So, questions on the ODP, because I'm not going to be able to handle lots of questions tonight in email, so please ask your questions now on the latest ODP.
So it's asking us to print each character or letter.
It's not asking you to print anything, actually. So your goal is as usual, to write a function. Your function is named mix. It takes in two strings and returns a string. Okay, so first detail, remember strings are always null terminated. If it's not null terminated, it's not a valid string. So you know that your two arguments, in this case A and B, are null terminated, meaning it's an array of characters. At the end of the characters that make up the string, there will be a character 0. That's your \0, your null terminator. Your goal in this function is to mix together the characters from A and B so that the output string is an array containing these elements: A0, B0, A1, B1, C0, C1, and then at the end a null terminator, because your output is supposed to be a string. I've had several people come to me already saying I'm getting 0 out of 10 on one of my tests, and in every case the problem is not having a null terminator on the output. So make sure you put a null terminator on the output. If you write your loops a certain way, that will happen for you automatically. If you write your loops a different way, it may not happen for you automatically, in which case write some C code to go ahead and put a null terminator in the right position. Yeah?
You said it returns a string?
Mm-hmm.
And
Sorry, the character star out, that third argument, is a string. The int, I don't know why I put it there, but I never tell you what that int value should be, so you can return whatever you want as the function value. But what I meant was the third argument out. That's the thing that you're creating, right? So specifically, out consists of the following followed by a null terminator. So that's the thing that you're building together as a mix of the two inputs. So, yeah, this is a good question. So let me come back to that, because I was going to talk about that as a separate issue. Did that answer your question? Because I sort of interrupted you when you started. Okay, all right. So don't print anything in this function. Mix the two functions together, store it in this output string. But I want to talk about this question. So suppose we have this is our main program here. Suppose we have an array of 100 characters declared in here, and we say something like function out. And the goal of our function is we want to change out to be a string that has 5 x's in it, for whatever reason, right? And then we're going to printf what out is. So normally when we call functions, we use this idea of a return value from the function. Inside the function, we say return parentheses some usually integer, and then when we call the function, we can say some integer equals that function. With strings, we're doing something different. We're actually passing a string into this function, and we're asking the function to change the value of that string. Now, we spent a while talking about pass by value and said we can't do that, right? Because if we pass an integer variable and we change it in the function, the value doesn't get changed, right? But because strings are pointers, if our function actually changes something in this string, that change will carry through when we get back to the caller. So let me do this. Integer function character pointer, and I'm just going to call this S. And suppose we do the following. So in my function, I'm going to take S, and it's an array, because it's a pointer to a character. It's an array of characters, so I'm going to set the first 5 elements equal to the character X. I'm putting a null terminator in the 6th position, which is S bracket 5, and then I'm just saying return 0. I don't do anything with that return value, but that's okay. So the claim is that when I come back here, out will now actually be equal to a string containing 5 X's, right? So let me demonstrate that, and then let's go into GDB for a minute and see how this is actually happening. Okay, and this is the behavior you want from your ODP. You want to pass a third argument, which is a character array, right, which you've defined to be big enough to hold the mix of your 2 input strings. And then mix should actually mix those 2 strings together and store that mixed string into this third argument out. And then when you come back, if you're testing this, you should be able to print out and see that it's doing the right thing. So let's throw this inside delimiters so we can see exactly what it looks like. And I'll be nice to the compiler and prototype my function. And I'm calling it S here just to make sure you understand that it doesn't have to be named the same thing that we're passing it, which is out. All right, so there's a function, func, that takes, I use S instead of S, takes a string S and sets some elements equal to specific values, and then it just returns a 0. And the claim is that changing these values in S actually changes the corresponding values in the array out.
Only up to the point of the 6th or the 5th one?
Only up to the 6th element, right, which is after the 5th character. You're absolutely correct. What did I call this crazy thing? So it works, right? If I run this, it prints out my output string is 5 X's. Exactly what we kind of hoped. Now, just for fun, let's not put the null terminator on there. And we get lucky, okay? but that may not always happen. But I think it's always going to happen today.
Why is it happening here without the alternator?
Because nulls are probably the most popular character in memory. And
So it's somewhere in there. From
It's-
something else.
well, it's probably right after there because, or the other stuff is unprintable. But let's go into GDB and let's see exactly what's in there. So I'll compile it with a -G. And then GDB it. Okay, so let's step into our function. So if I print S, S is an empty string right now according to GDB. If I examine this memory location, right, it's got a bunch of zeros. And looks like it's got 8 zeros in there. So yeah, we got lucky. Do I want to try to break this? Let's try to break it. It's the same program, but we're going to fill it with 8 X's instead of 5. Right. So now without the null terminator, we've got our 8 X's, but we've got gibberish at the end. Right. If we just go ahead and we put this in here, and we run it, then it works perfectly fine. So we lucked out before in that position 5 already had a null, but in looking at GDB, I saw that at position 9, there were non-nulls. And so by forgetting the null terminator here, we got gibberish at the end of our string. And we only got 3 characters of gibberish, but we could have gotten, big long string of gibberish. We could have had so much gibberish that it eventually flew into a protected area of memory and it gave us a seg fault. Let's save that for next class. All right. So let's look in GDB. So we're about to call our output function, and if we look at out, right, that's what it's got. If we look at the address of out is stored at this location that ends with E350, right? So let's step into our function, and our function is passed with an argument s, and if we print s, s is this weird number that ends with 350, right? So what's happening? Our function has a value which is exactly the same as the value of this. Well, we know that's true because C is passed by value. When we said func out, we actually said func 0x7ff blah blah blah. Was it E350? E350. And when we came down here in our function, S was equal to 0x7ff blah 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 E350. So what does it mean when we say S bracket 0 equals X? It means S is an array, okay? S is a location in memory. Go to that location in memory, set it equal to X. When we say S bracket 1 equals X, it means look at the value of S, add 1 to it to get to the next element in the array, go to that address, which is E351, and store an X. So what are we doing? If this is our memory map, we're going to this location and we're writing an X. And then when we say S bracket 1, it says add 1, which gets us to this location, write an X, write an X, write a null terminator. And when we come back in here and we say print out the value of out, what is out? Well, out is this number. So it says go to that location, print the character you find there, and in the next location, and so on until you get to a null terminator. So it's exactly the same string, right? Even though we passed a copy of out, right? Out is not the string itself. Out's the location of the string. We passed a copy of it, so if we had said something like s equals 12, that wouldn't change the value of out. But we're not changing the value of s in here, right? We're using s as a pointer. When we say s bracket 3, we're saying look at s, add 3. That's the memory address we're interested in. Go to that location in memory. So pointers kind of turn pass by value into pass by address or pass by reference, and let us do this kind of thing. So that's the long answer to how you pass these things back. And again, this is something we'll do all the time in 222. But instead of just passing strings, we'll be passing addresses of structures. And we'll define a structure that has, 50,000 different parts and pieces to it. But we'll pass the address where that first part or piece is. And then in our function, we can use that address to access the other parts and pieces. And what we change in the function gets changed in the caller. And that's how we'll move things back and forth. All right, so other questions on the ODP? Make sure you null terminate. And I'm going to say, if you're running into issues, post on the discussion before you email me. Okay, if you post something on the discussion board, I'll get an email about it anyway. And if I have a chance to dig into it, I'll dig into it from there. If you've got something that really has to come to my attention, like I can't log in, my cat changed my password, can you reset it for me or something, go ahead and send me an email. But it's just kind of generic wonkiness with the ODP or with the grading of it, right? Start off on the discussion board if you can. So other questions? All right, so I want to go back to algorithms. Oh, let me finish Makefiles first, and then I want to put you on the board in groups and have you start working on some algorithms related to strings. So we were playing with Makefiles yesterday. I just want to show you one other thing you can do. So I can say make and it'll build my program for me, right? And suppose I want to debug my program with GDB, right? I need to change all of these GCCs to GCC-G. And if you know VI, right, you can do something like this, right? And you're done. But that's a pain, right? And undoing it might be more of a pain. So here's a way to do this. I'm going to set up a symbol that I'm going to call compile flags. With a typo. Compile flags. And I'm going to say GCC and then $ parentheses compile flags says replace that with whatever the value of this thing compile flags is. Okay. So if compile flags is -G, this statement now says GCC space -G space -O blah blah blah. if I say make, I already moved my make clean, didn't I? If I say make, it compiles everything with this -G switch, right? So now I'm all set for debugging. But if I come in here and I just simply change compile flags to be nothing, so just compile flags equals with nothing after it, and I say make, it compiles without the -G switch, right? So I can turn my debugging on and off by just changing that first line of my make file. And sometimes you'll see things like this. When you pull down code from the web, usually it's going to have a more complex make file, right? One of the problems is we're all working on the same Unix system here, right? linuxengrcs.com. So we know that GCC is the compiler you're going to use. We know what switches to put on that and so on and so forth. But it may be that on some systems the C compiler is CC instead of GCC, or C++ or something like that. So I can make another symbol up here, C compiler equals, and I'm just going to set it to GCC. And instead of saying GCC on all these lines, I'm just going to replace this with the value of that symbol. And now if I wanted to compile with something other than GCC, I could just change this line, and all of these lines get changed automatically, right? So it's just generalizing your make file. And if you look at make files that you've downloaded for other systems, right, you'll see lots of stuff like this, and it gets really, really ugly really quickly. But we don't have to get too fancy with it ourselves, right? And so this is still just using GCC.
Do they use like an if statement or something to choose like which one?
Yeah, I think you can put conditionals and stuff like that. I've never really gone down that path. But because a lot of these make files will have a configure option where you say make configure, and then it goes through and it looks at your system and figures out what's the C compiler called, what's the version of the C compiler, what's the version of the loader, all this other stuff, and then it adjusts the make file accordingly. And then you go ahead and you do your make. And it's, yeah. I don't like make files that I download from the web. They almost never work for me. All right, so that's just an option to keep in mind. The one that's mostly useful for us is just this compile flags, because it lets you turn on GDB pretty easily and then rebuild. And let me put my clean option back here. Alright, so if I want to compile with flags, I can just set that to -G. It thinks it's up to date, so do your make clean, do your make, and now you got debugging turned on. So again, once you set it up, it's very rapid to change gears.
Is there a way to pass in compile flags via command line?
I think so. I don't know what it is, but I think there's a symbol, $ parentheses. I don't know, it's probably %1 or something strange like that. But yeah, there should be a way to make an argument and have it take that. All right, so let's play with strings, because I think the next few ODPs are related to string manipulation, and it's a good exercise in algorithms. Okay, so here's something to do. So let's write a function named reverse. And it takes in two arguments. The first one is a string that already exists. The second one is a string whose value we're going to change. And we want this new string to basically be the old string in reverse order. So if you pass in an old string of hello, then your output string should be this. If you pass in an old string of A, B, C, D, then your output string should be D, C, B, A. And if you pass in an empty string, your output should be an empty string, and so on.
What if two strings old and new are different lengths?
They gotta be the same length. You're only passing in this string and you're creating this string. So you're passing in sort of an empty string. Does that make sense? Okay. So what I'd like you to do is go into groups, go on the board, and write either a flowchart or genuine pseudocode for this. Okay, I don't really want to see completed C code. I want to see an algorithm for how you would do this. And it can be fairly straightforward. Okay, but what I'm after here is algorithmic development. So figure out the steps that you would use to take a string and then produce a new string that's the original string in reverse order. And let's see where we get with that. And then we'll go on to other ones. So I'm going to bring the lights up. Halfway. And now that's impossible to see. Let me try this. That's better. Yeah.
It's okay.
Is there markers?
Oh, yeah.
Oh, okay, that's how I think. I figured they're coming. Oh, yeah, they happen.
Now we're actually seeing code.
That's what I'm saying.
Right.
It could be 100 or
So it's line
maybe you can set the two strings. Yeah.
There's a new line
Then this is then you can make
That's fine.
yeah, the others.
pseudocode because we
We do have over the string.
Then, yeah, always bad at that.
or do you
Like, is there a picture?
just try to run these logic. Put in like A, B, C. If we put in for all,
It was like 3 hello. I don't know if this is what I'm sure somewhere
For loop is basically it's coming here and you just keep going back.
so I guess
Yes.
Well, no, we do a lesson.
We do a lesson on it. Well, it won't work if you try to call it right around. Like if the length is 25, it wouldn't work if you tried to call array index 25.
It needs a fix. You could say when it's less than or equal to.
Oh, that would say here.
Yes.
All right, so we'll still check on this.
So first time around, what is J? It would
So
be
now
0.
while is then equal to
And, yeah, no,
9, right?
Yes.
and I would be 5. For first time around, right?
It's implied, right? That's like again, this is an actual. That's what you're essentially doing.
That's the null.
Old doesn't have a.
This is why, so the length is 2 here.
Yeah, so new element J equals old element.
But yeah.
Yeah, right, I was forgetting about that.
So now I use
So look at the fourth spot, you still want to
So that's. It's like, length is technically 6. No, we don't know the null factor. Okay, so then you're fine.
Right, that
So
was.
why are we starting at 4? That would be S and L.
No, because this is 0.
Right.
Yep,
yep.
So that you see, okay, I can see it. It's just make 2 variables.
So, yep, so it goes
J adds to 1 out. Hold up.
Okay.
minus 1 between this L.
Programming here, it's hard to go back.
I feel like in today's data time is so cheap that there's no way.
Those 4 bytes aren't going to.
Right.
Yes.
Like,
Outline.
Alright, so let's read it.
It's less than 128 bits.
wait, but in the order, the second one. Or even if we are.
Oh, you're trying to find another.
Otherwise, I wouldn't.
Okay, can anybody see any
outside the realm.
We
want to do this.
Yeah. Oh, wow, that's true.
You know, you can get rid of any of
So what are A and, there you got it. A and 0, B is the string length.
Oh, actually, there is one thing.
Yeah, old is your input, new is your output. Oh, okay, no, that'd be fun.
But after that,
I was thinking
Let's see.
at that point,
Once you set this to
So we've got 2 things in your while. Are those ANDed or are they ORed or?
at this point we can add a new line.
Do they both have to be true or?
Yeah, but that's
Okay, so while B is bigger than 0 and A
Okay,
is
how many
less than
numbers?
or equal
Okay,
to.
okay.
No, it's just.
Okay, okay. Alright, sounds good. Sounds good. Okay.
Okay.
So are these things automatically controlled with the null?
We have to pass in
So where does the while loop end?
a null return or a. Right. I was gonna say outside of people putting in incorrect inputs, like there should be no anything. But in that case, like you try to do that to catch the arguments. Or anywhere else.
Yeah.
I think that's it.
Okay. So then the output's outside the while loop.
What is it?
So, okay. So I'm representing the data format. So I got an object. And those children. And let's say I want to go in and modify the value of the height. And this is going to access directly.
So my one question is, when you're done, is new gonna have an alternator at the end?
And just modify this value just by reference.
Just try it, set old equal to like AB and step through this and see exactly what it does and what gets written into new. See if it puts an alternator.
I want to let's say it's got a property.
So suppose,
There are 500
Yeah, so outside of having some sort of
well, you don't want that to come first. But suppose that whole go through your code and see what's new.
I just want to know how to go
So your goal is that at the end, new should be.
it's like say
Yeah. So see if it's doing that, and if it's not, then see how you can change that.
which this is actually an algorithm either one. So this is a
What is
point
my
that
face?
pointers to
Yeah, it's not.
Then he's so
The lab yet?
and this one just starts
Really?
so to traverse the tree, you can go
Yeah.
say you know if you didn't name like
Yeah, right. So what is length? String is HEL. So the data okay, so it's number of characters like content. So this is your test case over here. Hello, length is 5.
well, if you have all of those things indexed, like if you could figure out a list of like every single object that I'm going to have has these properties, you know, if you're going to have a hand object that has like whatever, you know. And this is just
Okay, cool.
one object.
So
that would be like one of these, and then you can otherwise it's not really. You can do it like this, but it'd be weird to just are you trying to program it C too? I don't know that much about C because it is object trees like this are really good for organizing lists of objects. Well, that's no.
So each of these is one.
Okay, right.
And then I connect like I can have another one.
So in that case, then there's something called a key, which is and so we do like if somebody put in an technically, otherwise you just do like assign number or something, you just have to keep track of those numbers.
There was some like
Objects. Something like that, and then that's the difference. Otherwise, right. Basically, what you're looking for is this kind of structure right here. You can start off at any given node in your tree, and each node will have a reference to the node above it.
We just need to check for
So like that's the simplest way to do that, right? And that's like one of the best ways that people figure out to do it. And it's complicated, but it's not super complicated.
Because we do this.
Then you don't have to worry about it. The name of this guy right here, the node, whatever node you choose to start on, you know, the name of this, what is the name of the node that I'm looking for, and then the left or right, and then you go to create the node. Does that kind of help at all? Yeah. Something you already knew, and just kind of thinking of computer challenges or whatever.
No, it's all good. The reason I bring it up is unless we're in the one
What do you guys think?
because I'm writing my report. Let's say object number 3 wants to modify its child. Let's say object 3 wants to modify child B. I want to make it so that object 3 doesn't necessarily have to know what. It doesn't have to know about its children in order for it to modify its children. Yeah, if that makes sense.
That kind of makes sense, but
So we could just do like a
there's a reason why it would have children in the first place.
But if it hits one, you don't have to check it to that.
Yeah, we could do that, but you would have to do that with like some sort of
What he said,
just like look up people, you've got like a list of like every single object and structure, and then like it's got some sort of reference, and you just look for that reference when you would it's like object 3 could be sitting right next to one of those children, but if it doesn't necessarily know that, then it would have to consult like some sort of say like, okay, so I'm looking at code B, and B is located at 134. Oh, well, it just so happens that right here, but you have to search for the object. So that's the reason why. Kind of. So that's the one of the like benefits of having a structure like this is that you don't have to necessarily like keep track of all these things. You can all have
Just making sure.
so
In my head. I was just trying to think like,
it's the last object inside a tree. Obviously doesn't have children, so that takes care of it. Sort of like, you know, we have to remember to cross this one out when we're done with this. And then the question is where do you store this list, how do you store this list, and how big does this list become, there's different elements in this list, or in this tree, does it actually iterate through the list and find it, or is it a full tree, or whatever, so. Again, don't know if that's helpful at all, but
No, it's helpful.
what I vaguely remember from the last couple of programming classes I took.
You take data structures.
Yeah, like wired
Unfortunately, I have to get this done this quarter.
J would be 0. So we're checking the last letter.
No, this segment. We've got like 5 different segments of this library.
Is this like a physics library or something?
No, well, sort of. So I'm making a game here.
So it's like,
And the game,
yeah, if we have a wood level.
so it's
We first start off.
you have these ships,
Change
spaceships
0.
here, The spaceship's custom defined different rooms. These are rooms here. So the rooms have different properties, like how much fuel is in it, how much air is in it. Represent you've got a big old vector of just air.
Because of this.
Yeah, representing this vector. And I'm passing those around. Right. But here's the thing. What if I have a room here that is childhood here? Because I want to make this game dynamic. I want to be able to not only, modify the values of the room from connections. I want to also be able to say attach that room, throw it out into space. Yeah. And that's the reason that I don't want necessarily I want to be able to dynamically update this reference. And I could just do a thing where I literally update every single item index on the tree. That gets expensive. Back in the day, so when I detach the child
If they all equal, just give us half.
Get rid of that.
I don't know.
Deconstruct object.
Because if there is no point,
If it tells looks for the parent of that, so it finds the reference object and it changes it. That's the only reference.
When I say reference, I mean just the index. So where this would be 0, 1, 2, 3, let's say I get rid of 2, now it's 0, 1, 2. I have to globally update it every time I modify the element.
No, not necessarily. Not necessarily. These don't have to They should be unique, but they don't have to necessarily be unique, if that kind of makes sense. So, like, you obviously have, like, a structure of the function, right? But that structure, just because you remove one room, what happens? So here's the question. If that room has elements connected, what happens if you take it?
If you remove those rooms, then that would become another tree.
And it would be like a totally separate.
Yeah.
Okay. So like you remove the parent and then just
just saying,
like spaceship.
Different problem spaces. So this looks mostly correct. My one question is, does this guarantee that you have it non-terminator on the output?
Well, we're just sort of assuming that it's going to get that terminator. And we can put our own terminator.
So if the string is hello, what do you want length to be?
So the length will be
Okay. String length will give you 5. So I is length is 0. Okay, it's not negative, so. Wow.
I will definitely worry about it.
This is the main let's see.
All right, so it looks like people have this. We're just about out of time, so let me give you something to think about, and I think this will be a future ODP. But along the same lines, try to write a function that takes in a string and then returns a copy of that string with all the letter X's removed. Okay, so taking a string like Taking a string like HEXOXHA and return a string which is exactly the same, but the X is already moved. Okay, and it's a little more difficult than what you just did, but also the output string is not going to be the same length. Okay, but it's the same idea. You're going to want a pair of pointers, one that's going through your input string, one that's going through your output string. And as long as you do the right things with those pointers, this is pretty straightforward. And this is something that you'll bump into again and again and again whenever you do string processing. Always want 2 pointers, one for input, one for output. It's a real common motif. So this is a good one to sort of think about. And we'll talk about it tomorrow, and then there'll be a future ODP that'll basically fly off this. All right, so I'll see you next time.
And not even have like